Bismillah ar-Rahman ar-Rahim. By the name of God, most merciful, most kind. Peace be upon you and God's blessing. In this video, we are going to have a discussion or introduction to the LU decomposition using Crout's method, but for 2 by 2 matrix. The items that we are going to discuss is the assumptions that Crout's method use to get the relations and the values of the lower matrix and upper matrix. The first assumption that U sub 1 equal to U sub 2 equals to 1. Number 2, convert matrix A to a lower matrix. This is, we call it option 1. Due to that conversion, we will get a lower matrix and we can specify the values of L sub 1, L sub 2, and L sub 2. This is one option. Number 3, we could use another option. We call it option 2. That is converting matrix A to an upper matrix. At the end, we will get L sub 1, L sub 1, U12, 0, and L sub 2. This conversion can be done by column operation, row operations, and elementary matrices. And the last point is to solve 2 simultaneous equations for the values of x and y. For LU decomposition Crout's method, it is written, it is possible to show that any square matrix A can be expressed as the product of lower triangular matrix L and upper triangular matrix U, but provided that the determinant is not equal to 0. So if we express the matrix A as A sub 1, A sub 12, A sub 21, A sub 22, and we let it be equal to the lower matrix, it is a lower matrix, then it has L sub 1, 0, L sub 2, and L sub 2, multiplied by the upper matrix. The upper matrix can be expressed as U sub 1, U sub 12, 0, and U sub 2. We have 6 unknowns, and we have 4 equations, so we need 2 additional facilities in order to know the other variables. That's why Crout's method, utilizing and make an assumption that U sub 1 equal to 1 and U sub 2 equal to 1. Then we are left with 6 unknowns, L sub 1, L sub 2, L sub 2, and for the upper matrix, already we know U sub 1 and U sub 2. We need to know U sub 12. We move to the next slide. Due to the multiplication of the lower matrix by the upper matrix and equating to the matrix A, we have 4 equations. L sub 1 multiplied by 1 plus 0 equal to the corresponding A sub 1. This is the first equation. Second equation, multiplying the second row by the first column, we get L sub 1 by 1 plus L sub 2 by 0 equal to the corresponding element, which is A sub 1. Third equation, multiplying the first row by the second column, will give us L sub 1, U12 plus 0 equal to A sub 12. And the fourth and last equation is multiplying the first row by the second column, L sub 1, U1 sub 2 plus, L sub 1 by U1 2 plus L sub 2 by 1. This will give us A sub 2. From the first equation, we can find out that L sub 1 will be equal to A sub 1. And from the second equation, since this term is equal to 0, we have L sub 1 equal to A 1. So this one, L sub 1 directly equals to A sub 1, and L sub 1 equals to A sub 1. But L sub 1, U12 plus 0 equal to A12, we are going to utilize this expression since L sub 1 equal to A11, we multiply by U12 and equate to A12. So U12 will be equal to A12 over A11, or we could write A12 divided by L sub 11. For the last equation, we can substitute L21 is A21, and U12, we just get the expression as A12 over A11 plus L22 equal to A sub 22. Then for the value of L sub 22, it is equal to A sub 22 minus multiplication of A12 by A21, all divided by A11. We move to the next. So we have here matrix A sub 11, A sub 12, A21, A22. We keep A11, A21. They will come to the lower matrix A, and this item in the lower matrix is 0. Then this item is A sub 22 minus U12 by L21, while for the upper matrix we have two diagonals. One element U11 equal to 1 and U22 equal to 1, and this value U12 is equal to A12 divided by A11. But how can we get these values? Through row operations and elementary matrices that we are going to see in the next slide. We move to the next slide. We call option 1 is the option we are going to use by converting matrix A into a lower matrix. When we multiply both L by U, we have L11, L11, U12, and this element is L sub 21, and this element will be L21 by U12 plus L22. This can be done by multiplying the first column by minus C12 over C11 and add to C12 to get it 0. At the end, we are going to get a lower matrix L sub 11, 0, L sub 21, and L sub 22. In the next slide, we are going to use numerical values for matrix A. We have 2, 3, 3, 4. In order to turn this into a lower matrix, we need this element to be 0. So we are going to multiply by minus 3 over 2, minus 3 over 2 by A11, and add to the C A12. Again, minus 3 over 2 multiplied by 3 added to 4, and we keep this no change for the 2 and 3. We get the lower matrix because we have here 2 and 3. Minus 6 over 2 is minus 3 plus 3 equal to 0, while minus 9 over 2 is minus 4.5 plus 4 is minus 1, 2. So we have here, this term is 0, L12, there is no. So we have L11 equal to 2, L21 equal to 3, and L sub 22 is minus 1 over 2. If we want to use the elementary matrices, we are going to use an elementary matrix, but we are going to multiply as column-wise, not as row-wise, to perform a column operation. So this is matrix A, 2, 3, 3, 4. We'll multiply by elementary matrix. We call it E1. We keep 1, 0 here. It means that this column will not change. We have 2, 3. And here is same operation. We divide 3 over 2 multiplied by minus 1. This is the term. And we keep this element as 1. 1, 0 column. And this is 2, 3 will be remaining same. Due to the multiplication, we have here 0 and minus 1 over 2. So we have used the multiplication of A by E1 to get L. So we can write that L equal to A, which is LU by E1. If we multiply both sides by the inverse L minus 1, we can write that L minus 1 by L equal to L minus 1 L by U by E1. This is expression. Divide by E1, which will let that L minus 1 by L is nothing but the identity matrix multiplied by E inverse of E1. It will be equal to U by I, which means that in order to get the upper matrix, we can simply get the inverse of the same elementary matrix E1 that will give us the value of U. Let us try. We have used an elementary matrix 1 minus 3 over 2, 0 and 1. We get the inverse by swapping 1 to 1 here, and it changes the sign. It will become 3 over 2 plus, and this term is 0, and we divide by the determinant, which is 1 minus 0. So this is the U value that we have already derived. We have diagonal equal to 1, and this term was plus 3 over 2. This is the first option. For the second option, we want to convert A into an upper matrix. So this is the matrix A, L sub 11, L sub 11, U12, L21, L21, U12 plus L22. We need this term to be 0. So we are going to multiply matrix A by elementary matrix, but this elementary matrix will be on the left side. The elements of that elementary matrix is 1, 0, minus L2, 1 over L11, and 1. When we multiply this elementary matrix by matrix A, we get L sub 11 and 0, L sub 11 U12, and minus L21 U12 plus L sub 21 U12 plus L22, which means that these two terms will cancel each other. Finally, we get L sub 11, L sub 22, L11, and U12. We can do that by numerical example. This is option 2 is to convert A into an upper matrix. We have this matrix A 2, 3, 3, 4. We need this element to become 0. So we keep the first row and we use this as a pivot. We divide 3 over 2, multiply by minus 1, add to the second row. So we have minus 3 over 2 R1 plus R2, raise the value to R2. First row is 2 and 3 will be the same. For this element, we have minus 3 over 2 multiplied by 2 added to 3 would give us 0. While for this element, we have minus 3 over 2 multiplied by 3 added to 4. We have 2, 3, 0, minus 1 over 2. This L sub 11 equal to 2, while this element is L sub 11 U12 equal to 3. We could divide L sub 11 U12 over L11. So we divide 3 over 2 to get the value of U12. And the last element, L sub 22, is minus 1 over 2. We are going to do that by elementary matrix. So again, option 2, converting A into an upper matrix. This time, the elementary matrix E will be on the left side. The first row of the elementary matrix is 1, 0. The second row is minus 3 over 2 by 1, which is minus 3 over 2 here, and 1 is here. First row 1, 0 will keep the first row no change with 2, 3. Minus 3 over 2 and 1 will give us 0 and minus 1 over 2. And this is the value of L sub 11 U12 as we have estimated earlier. Now we come to the two simultaneous equation. For two sets of equations, we have 2x plus 3y equal to 13 and 3x plus 4y equal to 18. We want to solve and find x and y using Crout's method. This is matrix A, 2, 3, 3, 4, the same matrix we have we utilize to get the values of L and U. We can write the expression AX equal to B as 2334 multiplied by X and Y equal to B, which is 13 and 18. We have obtained earlier the lower matrix. We keep this element 2 and 3, and this element is 0, and this is minus 1 over 4. While the U matrix, we have a diagonal 1 and 1, and this is 3 over 2. And the X and Y equal to 13 over 18. We can take UX equal to C. So LUX can be expressed as LC equal to B. We have already the lower matrix L as 203 minus 1 over 2. We want to get the inverse matrix L sub 11. We have seen before that we can get it through swapping minus 1 over 2 will come here and 2 will go down and changes the sign. Minus 3 will become here, and here we have determinant of minus 1, so we divide by minus 1. This is the L sub L, the inverse of L is 1 over 2, 0, and plus 3 minus 2. We refer back to that equation. If we multiply both sides by L minus 1 inverse, we have L minus 1 L by C equal to L minus 1 B. So we get the value of matrix C as equal to the inverse of L multiplied by B. This is the inverse of L, 1 over 2, 0, 3 minus 2, multiplied by B, which is 13, 18. We get 13 over 2 and 3. While this is the U matrix, we have 1, 3 over 2, 0, and 1. Its inverse would be 1, 1. Change the sign, minus 3 over 2 and 0. The determinant value is 1 minus 0, so no change in the sign. Using the expression UX equal to C, we multiply both sides by U minus 1. We get U minus 1 UX equal to U minus 1 C. This term will become I multiplied by X. This U minus 1 by C, U minus 1 is 1 minus 3 over 2, 0, and 1, multiplied by C, which is 13 over 2 and 3. This term 0, 1, there will be no change. The 3 would be the same. We have 1 multiplied by 13 over 2 plus minus 3 over 2 by 3 is minus 9 over 2. We get X vector is 2 and 3, which means that X value is 2 and Y value is 3. We are going to check the values of X and Y in the two simultaneous equation. We have 2X plus 3Y equal to 13, which means that if we substitute X by 2 and the value of Y as 3, we have 2 by 2 plus 3 by 3 equal to 13, which is the right hand side. While for the second equation, we have 3x plus 4y equal to 18. So 3 by 2 plus 4 multiplied by 3 will give us 18, is the right hand side. There is another way. Instead of going by to use matrix C, we could use the expression LU equal to A, and we get the inverse, multiply the left hand side by L minus 1 by U minus 1. This will give us the value of X directly. Again, this is A, 2, 3, 3, 4, X and Y equal to 13, 18. We can express AX equal to B as LUX. Multiply here from the left side by the inverse of L. Again, we multiply by the inverse of U. And the right hand side would be multiplied by the inverse of U multiplied by the inverse of L by B. These all terms, first we start, this one is I, and again u minus 1 by u is again I. So I by x equal to u minus 1 L minus 1 b. Through multiplications, we will get the same value, x equal to 2 and y equal to 3, which is the same result. We have come to the end of our video. I hope this video was useful. Thanks a lot, and God bless you all. See you next. Take care.